All right, good morning, everybody. My name is Nathaniel Skidmore, and today we're going to be taking a look at evidences of a chemical reaction. Now, this is going to be a middle school oriented style lesson, and we're going to be looking at the Alabama Course of Study Standard 5. Observe and analyze characteristic properties of substances, things like odor, things like density, solubility, flammability, melting point, boiling point. Before and after substances combine to determine if a chemical reaction has occurred. We're going to be going through these evidences, we're going to be exploring some of them, and we're going to hopefully hit all 5 E's of science learning: engage, explore, explain, elaborate, and evaluate. So, first thing we're going to do is we're going to have some sort of entry ticket activity. And what that's going to do is it's going to kind of get our brains moving and see where we're at and try to see if we can all start thinking about science together. So what we're going to do for our entry ticket is we're going to write down 3 ways that I can tell whether a reaction is a chemical or a physical reaction. Now, this lesson is typically following an introduction to the base ideas of a chemical reaction and a physical reaction. And what we're going to do is see if we can activate some of that prior knowledge that we have. In this way, we can remember what we did on the previous lesson and try to see if we can apply it to what we're doing now, which we can. This is going to be a very good application process. So what we do is we take a minute or two, we write down our ideas, and then we have an opportunity to discuss our ideas. And we do that by having a fishbowl discussion. So what we do is we have our time to think by ourselves, to write down ideas by ourselves, and then we turn to our groups. We start asking them, what did you put down? Why do you think that's an evidence of a chemical reaction or a physical reaction? It's a good way to start talking with your classmates and having opportunities for that discussion, because that discussion is where we can learn the most about what we're doing by being able to explain it and verbalize it in our own words, not just be able to hear it and regurgitate it. We need to be conversational with what we do in science. So you turn to your group, and maybe if you didn't get 3 down, maybe you only got 1 or 2, your group mates can help you, and they can help build your knowledge base. So combined, you're going to get a really good idea, and maybe overall, as a group of 4 people, maybe you can get up to about 4 or 5 different ways you can tell whether a reaction is a chemical or physical reaction. So that's fantastic. Then what we do, after we have had the opportunity to think on our own, had the opportunity to communicate with our group, then we have an opportunity to verbalize it to the whole class. So you go through and you ask the groups, what's some evidences your group came up with? Okay, did anybody else come up with those evidences? Well, maybe someone came up with something different. Then we have an opportunity to have that whole group discussion. So, we've been able to address our prior knowledge in just about 3 to 4 minutes on an individual level, on a small group level, and on a whole group level. So that's how we can start our lesson. That's how we can activate our prior knowledge and get everyone in a mode ready for science. So then we go from there and we hit our engage really hard. And what we're going to do is we're going to perform a little experiment. This can be done very simply at home. And what I do is I use lemon juice for this. So I take a bottle of lemon juice, and if you don't have like a little dish to pour it in, and you don't want to be wasteful with it, what I do is I unscrew the cap and I just pour a little bit into the cap. I just got a little bit of that on my table there. That's nice. And then what I do is I take a little Q-tip here and I dip it in the lemon juice, and then I draw something on a note card. So I'm going to draw a little smiley face here. All right, let me show it to you. I don't know if you can quite see it. Sometimes you can see it a little bit, and you'll need to give it some time to dry. So what I did was, earlier in the day, I did the exact same thing to this note card. Now, I got 3 note cards total here. I got the one I just drew on, which you might be able to kind of see what I drew there. I got the one I drew on earlier, which you can't see. And then I got this completely blank note card. Now, can you tell the difference between these 3 note cards? No, that's because what we're doing is called invisible ink. It dries into the paper and you cannot see what is on this note card. Now, I told you I drew a smiley face on this card here that I just drew on. I did the same thing with this one, so there will be a smiley face appearing on here. So you give the students the opportunity to do their design, or if they're doing this completely on their own, they have time for it to dry, and then what they do is under careful lab safety procedure, you expose it to some kind of heat source. This can be done with a hair dryer. This can be done with one of the older light bulbs, and this also can be done with a candle. I prefer a candle because I have them just lying around. So I take the index card and I expose it to heat. This can be done with any kind of paper, but I prefer index cards just because they're a little bit thicker than something like printer paper, and I want to make sure that the paper does not catch fire before the reaction has had time to take place. So I'm giving the reaction a little bit of time here. Sometimes it takes it a minute or two, and that's just fine. So I'm just going to set it on there and leave it. Actually, I'm going to move it because it's starting to react pretty well. But normally this can just take a few minutes, but I've been very well practiced in this, so I've got this down pretty quickly. And what we're going to see here is that previously blank note card has a little smiley face on it. Isn't that just wonderful? That's what we're going for here. The blank note card that we painted with lemon juice, when exposed to heat, revealed an image. And that is the engagement part of our lesson. We're getting the students to realize that, we didn't see anything on this note card, but when we exposed it to heat, we seen something. That's engaging. That's like, wow, how did that happen? And that's exactly what you want them to ask. And that's why we have these little observation guides. These observation guides, sometimes I'll just refer to them as guides, are going to help our students think about what's going on critically and see if they can not only just think it in their head, but put it into words on their paper. So, describe the chemical reaction you just observed is our first point. And you'll have digital copies of this that you can refer to. So that way you can see everything I'm referring to on the sheet. So, describe the chemical reaction that you just observed. So what I did was I took the lemon juice, I put it on my Q-tip, and I drew on the paper, and it disappeared, and I couldn't see what was written on it. But then when I heated it up with the candle, I could see what was written on it. Okay, so that's describing the chemical reaction we just observed. What observation can you make about that chemical reaction? Need at least 2 observations. And I make sure to put need at least 2 observations because I want students to be able to be held accountable for their learning. You want to be able to show something, show growth from it. And that's how we can do this, by having at minimum 2 observations. So what you can do is there's a bunch of different observations we can make. We can observe that the lemon juice, when we took it and we painted it on the note card, it dried up and went into the note card, and then we couldn't see what we wrote. Okay, that's a very good observation. Another observation we can make was, you couldn't see what was written on the note card, but when you heated it up, you could see what you had originally written on that note card. That's another really good observation. Here's a third one. So I'm going to go a little above and beyond here. There was a change in color that we observed. It went from clear to sort of like a coffee stain kind of color, a little bit yellowish, brownish. So I'd say coffee stain would be a pretty good color for that. So what additional questions do you still have about the reaction as presented? You need at least 1 question. Now, I don't want to be too demanding with how many questions I require because sometimes things just make a lot of initial sense or you don't really know how to think of the questions. So with this being more of an entry-level assignment, I'm only going to require a minimum of 1 question. So what additional questions do you still have? There is one really big question that we still have. How do we paint something invisible on here that when we heated it up we could see it? That's a really good question. That's a bit of a run-on form and not very professionally worded, but that could be what you get from your students. How did we heat up a note card that we couldn't see what was written on it and be able to see the message? So that's the question that we still have about the reaction that was presented. And then we get to our final question here, and I really like this question. What are different ways you would want to modify this experiment, and what do you think the new result will be? You need at least 2 modifications. The engineering design process is being reinforced really hard in our schools, and that's very good. You want students to be able to think about how they can change things and what the new result would be. That's a very high-level critical thinking. That's evaluating the situation. That's creating something new. That hits the top levels of Bloom's taxonomy. And we're going to do that abstractly by just thinking through it critically. So what are two different ways you'd want to modify this experiment? Well, what if I used a lot less lemon juice and just barely put any on it, and it dried super quick? What do I think the new result would be? Well, I don't think I'd get as pretty of an image. To get this pretty of an image, I had to really cake on a good bit of lemon juice. But I also only let it dry for about 30 minutes. So what is a different way we can modify the experiment? What if we change the solution involved? What if I just used water? What do I think the new result would be? Well, I don't think the oxygen coming from the candle would bind to the water at all in a way we could read, so I don't think we'd see a result there. But that's good, it lets you think about it critically, and it lets you be the scientist and try to think of what would this new reaction be. And these little learning guides here, these little observation guides, students are going to be accountable for multiple of them throughout this lesson. And that was the one we filled out for the engagement. And now we can start looking at exploring, explaining, and elaborating. And we're going to do that through playing a little game here. And I'm getting real close because I'm going to change to this screen right here. We're going to go to the Legends of Learning link that I provided, and it's going to pop up and it's going to look just like that. So we're going to go over to our Legends of Learning, and we actually don't want this game that pops up here. We want to scroll down to this cute little mouse here called the React Lab. We're going to click on it, and we're going to click on Try Game. And this is the game that we're going to be playing. And we're going to have about 3 to 4 more of these sheets, just like this one, that we're going to fill out throughout the process of this. And this is just to give us additional reinforcement of, here's how I look for an observation. Here's how I describe the reaction. You want students to have that opportunity for repetition in your classroom. And this can be done very easily virtually. There's nothing we've done so far here that would require students to be in a classroom. So let's take a look at this React Lab here, because we're trying to look at how we can virtualize different aspects of science learning to deal with the current environment we're in. So everything we can do here, we can use Legends of Learning. Legends of Learning is a fantastic database of science and math games going from elementary school all the way up to middle school. And this one in particular is one of my favorite games, the React Lab. So let's read through some of the information we got here. In a chemical reaction, reactants rearrange the atoms. Bonds are broken, atoms are rearranged, and new bonds are formed, giving rise to products. So that gives us an introduction to a chemical equation. We have our reactants here on our left-hand side, and we have our products here on our right-hand side. We also have our little yield symbol. So products have different chemical and physical properties than the reactants that form them. Properties that can change include density, physical state, boiling point, melting point, solubility, flammability, color, and smell. Does that sound exactly like Standard 5? Yes. So, evidences of a chemical reaction. The biggest takeaway from this, we're looking at evidences of a chemical reaction. This slide right here will give us our best definition of it. The evidence that there was a reaction is seen through different signs in the products, such as a change in color, a change in temperature, the release of a gas, dissolution, the precipitation of solids, the separation of liquids, or the change of odor. Hopefully not too much of change in odor, because I do not want a smelly lab. Dan is a little mouse who loves chemistry. Help him solve different riddles with the help of chemical reactions. And that's what we're going to be doing. We're going to be filling out 3 to 4 more of these sheets just like this about different reactions that we go through. And that's what's going to be exciting here. We went through a reaction physically, and now we're going to go through one virtually. Just because we went through this one physically does not mean it has to be done in the classroom. This is a very easy lab to do at home. You've seen me set it up in my own home very quickly. So, React Lab, level 1. And what we're going to do here is we're going to equip ourselves to start the journey. We're going to follow proper laboratory safety procedures. We're going to put on boots, safety glasses, mask, gloves, and a lab coat. Those are going to be our reactants, and they're going to yield equipped to start the journey. We have a chemical equation, how we're going to prepare ourselves for lab. So we put on all of our equipment. We got on our safety glasses, our gloves, our boots, our lab coat, and our mask. So we're going to be protected from dangerous exposures in a chemical laboratory, such as vapors, odors, high temperatures, acids, and flames. And we're going to be prepared to handle those. So, level complete. We earned 3 blocks of cheese. That's good. Continue. The door is very cold. You can see the exit up here is made out of ice. We need to melt it. Ethanol and oxygen react to generate heat, and we're going to talk about this level in terms of what we're going to need to fill out our observation guide. So what do we need? Ethanol and oxygen, and they're going to react together. Those are our reactants. So we're looking for C2H5OH and 3 moles of O2. So, do we see them anywhere? We see C2H5OH. Okay, we grabbed it. That's ethanol. We see 3 moles of H2. Those are our reactants. Now we take them over to our reaction station up here, and we're going to combine them. We're going to combine them by hitting start, and our product, 2 moles of carbon dioxide and 3 moles of water, and a temperature increase. So, we're going to click OK, and look at the exit door. It melted. Describe the reaction you just observed. We combined ethanol and oxygen gas to form carbon dioxide, water, and heat. The heat was used to melt the ice at the exit gate so that we could progress. So we described the chemical reaction. What observations can you make about this chemical reaction? Well, an observation is that it produced water and heat, so that's pretty cool. It produced both a liquid and a temperature. It also produced a gas, carbon dioxide. See, it produced all kinds of things. It produced a lot of things. We can also observe that since it did have heat in its products, it would be exothermic reaction. That'd be our second observation. What additional questions do you still have about the reaction as presented? How well would this reaction melt a physical block of ice in a classroom environment? That'd be a really good question. I would love to see that reaction take place. So what are 2 different ways you'd want to modify the experiment, and what do you think the new result will be? Well, we could substitute oxygen gas for a different gas. What do we think the new result would be? Probably no reaction. If I switched oxygen gas or maybe chlorine gas, I don't think we'd get a reaction. What's another way we could modify the experiment? Well, what if we mix them in different proportions? What if we had a whole lot of oxygen gas and only a little bit of ethanol? Well, then we'd get into the idea of a limiting reagent, and we wouldn't be able to produce a whole lot of heat because we'd run out of ethanol. So then maybe we wouldn't be able to melt the ice and make it out. So that would be a good modification that we could make and a good potential result that we could have. Now there are a bunch more levels on here. I'm going to walk through one more, but we're not going to look at how we answer our guide. We also earned 3 blocks of cheese here. That's very nice. So, the water is deep and we need to push the boat. A chemical reaction of sodium bicarbonate and hydrochloric acid generate carbon dioxide in the form of bubbles. So what do we need? We need sodium bicarbonate and hydrochloric acid. So we need NaHCO3 and HCl. So, do we see it? Do we see it? I see NaHCO3, sodium bicarbonate. I also see hydrochloric acid, HCl. We're going to take it over and we're going to react it. So we're going to form our reaction. We produce carbon dioxide as a gas. We produce salt and we produce water. So I walk over here. I get into my little boat and I go over to the other dock. And I can make it out. So that's the kind of thing students are going through with this React Lab. I'm actually going to go back to our original screen here so you can see me. So students have an opportunity to go through that and complete all the levels. There's about 6 or 7 or 8 levels. You know, you got a good amount of variety. Now, a different way you could differentiate this lesson is different students having different requirements about the amount of sheets they need to complete. If someone needs a whole lot of reinforcement, you know, maybe you have them do an extra sheet, or maybe if they struggle to complete their assignments, you know, maybe they do 1 less sheet. Students still need at least 2 to 3 reps on their own to be able to complete this. Now, the initial one that we do as a whole group, where we make the little smiley face or whatever they wanted to draw, you know, that's the freebie. That one we do to see how we do it correctly. And then we take that and we have the opportunity to do it on our own. So we do it 2 to 3 times on our own, or maybe 4 if we need to. And that should give us enough reps and repetition to be able to complete this properly. So, that concludes the body of our lesson, and we can get to our closing activity here. Our closing activity will be the opportunity for us to discuss. So, we're going to go to one of our neighbors here, and we're going to talk to him about the different reactions that we observed. Now, if we don't quite remember what went on, that's why we have the observation guide. The observation guide can give us, if we complete it correctly and honestly, a very good retelling of what happened in that reaction and what all we think about it. You know, we had opportunities to describe it, had opportunities to observe it, had opportunities to question it, and had opportunities to modify it in theory. So, we took those modifications in addition to all this and predicted what we think would happen. So we have a very complete picture of this reaction that allows us to explain what we saw to someone else and them in turn to do that to us. Now, another way we can differentiate the assignment is you have an additional sheet, an additional observation sheet that a student can complete based on what they heard from another student's reaction. So maybe I chose not to write about reaction 4 in the React lab. That's fine. Another student did though, and I talked with them and they described it to me, and I completed my observation guide based on that description. That'd be a great way to get students to practice not only writing down the information, but verbalizing what they wrote down to try to explain what they saw. And being able to explain what you saw and be able to explain your predictions are very good things that we need to do. And that's how, with this lab, we hit our explore. We explored what we did in the lab. We also explored what would happen if we heated up lemon juice on an index card. We explained what went on when we looked at the evidences of a chemical reaction, the flammability, the solubility, the melting point, the boiling point, the change in odor, change in color, the evidences of a chemical reaction. We explained them, and we got to see some of them in that lab, especially with the temperature increase. So, we elaborated. We took a very simple reaction and we discussed what went on in that reaction. You can't quite see the drawing when it's all the way back there. You can see the drawing up here. We elaborated. We took our initial observations we made on our observation guide, and then as we progressed, they became more and more sophisticated. We started to make better and better observations, better and better predictions, and that's the goal here. We elaborated. And now we have the opportunity to turn and talk, and we have the opportunity to evaluate each other. The students get to evaluate what the other students did and try to help them with their questions, with their observations, connecting their knowledge together and helping build a better knowledge base. So that's our turn and talk. So students have the opportunity to communicate what they've been working through. And I'm very big on formative assessment. You know, throughout this lab, you can ask them, you know, what reaction are you working on right now? Oh, I'm working on reaction 3. Well, what's going on in reaction 3? And they're like, oh, well, this is going on in this reaction. Okay, why did you choose the reaction? Oh, because I really liked the result it yielded. I thought that was very interesting. Okay. So that's very short questions you can ask your students, and you can have those discussions. And they can have the opportunity to verbalize what's going on, and you have the opportunity to hear that and be like, okay, they're on the right track, or okay, no, they're not. How can I help them get there? So students have the opportunity to evaluate each other in that turn and talk session. So that gets us to the end of the core instruction for this lesson of evidences on a chemical reaction. And then we have our preview of the next lesson activity. It's a little exit ticket. So now you've handed in all your observation guides, and those are going to be checked to make sure you did them and you were honest in your answers and you wrote down proper observations and questions and modifications that made sense, and that's going to be fantastic. So our preview of the next lesson is a little exit ticket activity, and it's going to be very similar to what we did for our entry ticket if you remember back to the beginning of the video. We're going to write down 3 potential ways that a reaction can be identified as a physical reaction. So that previews the next lesson to be all about physical reactions, and that's going to be very exciting, but that's covered in a whole different video. So overall, we hit our engage with our reaction we did with the lemon juice. This is the one that I made at the start of the video that you all watched, and as you can see, it has become completely invisible during this lesson. So that's why it's important that if you're going to do this for a demonstration, you either do it ahead of time or you make sure that when you write with the lemon juice on the index card, you go very lightly. We hit our explore. When we looked at our observation guide, we started asking some questions. We started making some modifications and predictions. We hit our explain. When we looked at our React lab and we had our evidences of a chemical reaction listed and then had examples of those listings provided for us during the virtual lab. We hit our engage, we hit our explore, we hit our explain, we hit our elaborate. And we tried to push our learning further. As we progressed through our different observation guides, we got more and more sophisticated with our observations. We got better and better with our questioning. We elaborated. We hit our evaluate when we had the opportunity to talk with each other as students and say, here's what I observed on this. Here's what you observed on this. Okay, why did you make these observations? And we were able to build each other's knowledge base up, and that's fantastic. And then we were able to hit all 5 of our E's: engage, explore, explain, elaborate, and evaluate in a virtual environment. Now, just remember, this Legends of Learning is a fantastic database for all kinds of science and math games. So I would definitely encourage you to go to Legends of Learning and take a look at the different games they have to offer, especially for the middle school level. It's a fantastic middle school tool. All right, that's going to bring us to the end of the lesson. Thank you everybody so much for listening.